Good morning, guys. Today's 17, college algebra. We're going to be looking at rational expressions. For your next quiz, which will take place probably at the beginning of next week, the vast majority of your quiz will consist of the ability to factor things, or the ability to manipulate polynomial expressions through simplification, meaning can you factor, can you distribute, the opposite of that. The vast majority of this quiz will be that way. And that means that if you are struggling with this, you will have lots of practice on it for the next couple days, which I think of as a good thing. Because if I'm struggling with something, I should try it more, not run away from it. And so in this case, we're going to be looking at a lot of different problems and showcase kind of the major ways you use factoring in different ways, and how you can use factoring and distribution in the same problem sometimes, depending on what your larger goal is. And so for these problems, just note how they kind of fit together and be very clear about how the process works. Because if you don't understand the factoring portion, today's material becomes torturous and it is not fun at all. Okay? That being said, look forward to that quiz probably on next Tuesday. Then we'll have 2 more days of material, and then we'll take our post-test and be done. So, that's it. We only have 7 days left, including today. That's crazy. All right, let's go ahead and get started. Okay, today we're primarily dealing with something called rational expressions. Now, a rational expression is any function which contains a numerator and a denominator in the same expression. So, in many ways, something like 3 over 4 is rational because it's a fraction. However, a rational expression would be to include variables in these things. This is a rational expression. It's a fraction which contains our 2 main components, the numerator, which is the top part of the fraction, and the denominator, which is the bottom part of the fraction. You have to know both and how they fit together in order to make sense of some of the math we're going to do. In general, the denominator is the more important part of the function. And you'll discuss farther along in your college algebra classes why that's the case. But it should be noted that in general, the numerator is less important than the denominator. The denominator dictates a whole lot more things when it comes to the graph, when it comes to things like how to determine critical values. There's a lot of pieces there. So let's go ahead and take a look today at the primary purpose of what we're going to talk about, simplifying a rational expression. Now, we've used this word simplifying a lot. Simplifying just means to reduce complexity. Now, in this case, the simplification we're referring to is to either reduce the numerator, denominator, or preferably both, or if there's more than one rational expression, to combine those two together. So this is a problem with one rational expression. If I was to look at one that had 2 rational expressions, I might have 2x over x minus 4 times x squared minus 4 over x minus 8. These are more complex than if I was to merge them together into one function. And so our goal with simplifying is to reduce complexity, as it always is. Now, the big steps we're going to talk about today, we're going to first start by looking at just a simple rational expression, which is today's material, and how to simplify it. The first thing you should do is you're going to want to factor the numerator and the denominator. So there's going to be 2 factoring problems today. You have to factor the numerator once, factor the denominator once. And it should be noted that this is if possible, meaning it is possible that they do not factor. So make sure to check. Second thing, cancel what are called common factors. Common factors are any factors which exist in both the numerator and the denominator. So for example, if I was to write a radical expression, kind of like this, so x times x minus 2 times x plus 3 all over x times x plus 3 times x minus 5. If I was to write this as a rational expression, there is a way to write a simpler version of this where we cancel out the ones that they have in common. In this case, we can cancel the x's because they're in common, meaning that they are both factors of the top and the bottom. Note here, factors implies that you have to be looking for things that are being multiplied. So x is being multiplied to these two, x is being multiplied to these two, so it's a factor, so we can cancel on top and bottom. And we can also cancel the x plus 3's, which are each on top and on bottom. In this case, leave me with the function x minus 2 over x minus 5. This function will act the same as the previous one in almost every sense. There's a few exceptions to that rule, which we'll get into later on in your college algebra career. However, in general, this function and the other function are the same, and yet this one is reduced in complexity. So we'd rather have this one. Math people would rather deal with that function than deal with the other function. The problem is we're not usually going to get it in this form. We're going to get it in, multiplied form, where it's already been distributed, already been FOILed, and that means that our job is to put it in this form by factoring the top and bottom, the numerator and the denominator, and then canceling those common factors as we see fit. Like I said, a big part of today is going to be, can you factor? If you can't, then it's going to lead to some trouble. So, let's take a look. For our first problem, we have the following function: x squared plus 8x plus 16 all over x squared plus 11x plus 28. So, step one, our main goal is going to be to factor the numerator and the denominator. So we need to take this function, we need to write it in a new form where the top has been factored and the bottom has been factored. Like I said, you get a lot of practice with factoring in today's problems. So I'm going to come up here and I'm going to factor this function. I see that my two values are 1 and 16 because my a is a 1 because I have a single x squared. My 16 is my c. I multiply those. So this is my AC. And now I want factors of 16 that will add to 8. In this case, those factors are going to be 4 and 4. Again, you can use whatever factoring technique you're choosing. I'm showcasing one of the ones we talked about before. It's just, a different way of approaching it. I can then factor that expression. So x squared plus 4x plus 4x plus 16. I take these two, I take the 8 that was in the center and turn it into my two numbers, 4 and 4. I then do factor regrouping, allow me to take an x out, allow me to take a 4 out. I write my two pieces, x plus 4 and x plus 4. Ooh, they're all the same, look at that. X plus 4 on top times x plus 4 on top. I could also write this as x plus 4 squared, because remember, anything times itself is just squared. But in this case, I kind of want to leave it in this form to make it easier to cancel later on. Okay, now I do the bottom one. Same deal. So my numbers are 1 and 28. Multiply those, we get 28. That is my AC. And I'm looking for numbers that compose 28 but add to 11. They would be 7 and 4. From there, I have x squared plus 7x plus 4x plus 28. I break down into my two pieces. I take an x out of the first one, which would make this x plus 7. I take a 4 out of the second one, which would make this x plus 7. They match, that's a good sign. I get x plus 7 as my first term and x plus 4 as my second term, giving me my factored forms for each expression. So now I've got my problem put into its two factored forms. Obviously, if you can make this process faster, you will make this problem faster, because this is by far the biggest time sink on your problems today, is your ability to take these functions and factor them. So if you factor these faster than I just did, good. You're probably using a faster technique. Good. Keep doing that. Don't change. I'm showing as much work as I can for those people that need it. At this point, I now want to have done step 1. Right, I factored the numerator and denominator if possible. It was possible. I did it. Now I want to cancel common factors, which means that anything that exists on both the top and the bottom being multiplied, I want to cancel. So I see here I have an x plus 4 and an x plus 4. Which x plus 4 should I cancel? Doesn't matter, as long as you cancel one of them. I can only cancel one of them because there's only one on bottom. I can only cancel an even amount. So I can cancel one on top with one on bottom. If I have two on top, I have to cancel with two on bottom, or else I can't cancel both of them. From here, I can now write my x plus 4, which is from the first one, and my x plus 7, which is the second one. This is a fine way to write your solution, but rarely the way math people like to write it. We'll drop those parentheses to write x plus 4 over x plus 7, and that is the more common solution you'll see. And so we took this function, which contains a power of 2. The top numerator function is a second degree trinomial. The bottom is a second degree trinomial, whereas we change this into a first degree binomial in both the numerator and the denominator. So we have reduced complexity, therefore it is simplified. Example number 2. Okay, my next example is x squared minus 9 over x squared plus 4x plus 3. Let's say plus 4x. Handwriting's atrocious today, as always. Okay, my goal becomes, step 1, I want to factor the numerator and denominator if possible. Now, I look at this and I see difference of squares, because I have x squared and I have 9. I know 9 is 3 squared, meaning I can shortcut that process by a little bit. Rather than having to use things like the AC method or any other methods, I can jump straight from here to here because I'm using difference of squares. So knowing your different shortcuts and techniques is just going to cut out a lot of your work. So again, you are not forced to learn difference of squares, but you're still going to be working on this part when I'm already done with this problem. Okay? So keep that in mind. On bottom, I know it's going to break down to factors. I'm going to again use the AC method. You can use, again, any technique you want as long as you're getting your results. My numbers are 1 and 3. Multiply goes together. I get 3. I have 4. That means my numbers are 1 and 3. I get x squared plus x, this is 1x, plus 3x plus 3. I group, and then factor. Take an x out of the first one to get x plus 1. Take a 3 out of the second one to get x plus 1. Those two match, that's good. I get x plus 1 as my first parentheses, and x plus 3 is my second parentheses. Now, if you did this in a different order, your x plus 3 may be over here on the left as opposed to being on the right. That doesn't matter. Look up here, right? We were able to cancel x plus 3 on the left and x plus 3 on the right because they're all factors. Factors are being multiplied, which means we can cancel them in any order. So the x plus 3 on the left and x plus 3 on the right, since one's on top and one's on bottom, they cancel just fine. I then come over here. I'll look for, okay, we want to cancel common factors. X plus 3, x plus 3. That leaves me with the reduced complexity of x minus 3 on top over x plus 1 on bottom. And here's the thing. If you were to look at these two functions, everyone could agree that this one is simpler. It's more simplified. If you were to look at the graphs of these two functions, they would look very, very similar. In fact, there's only one difference between these two, and I'll show sometime what that is looking like, especially if you take my college algebra class at my school. Because that's really important, is to note that these two are very similar, except usually in one place. So, this is your goal today, is to reduce the complexity, to write a simpler version of a complex rational expression. And we do that by factoring the numerator and denominator completely, and then canceling any common factors. I have two more examples, so let's take a look at them. Alright. So again, my goal is going to be, we're going to attempt to factor the numerator and denominator, and then we're going to cancel any common factors. Example. Alright, in this example I have x minus 6 on top over x squared minus 36 on bottom. This one's relatively simple to do. especially if you know your pieces. But it's important to note here that the top does not have a factor. It is just x minus 6. The bottom does factor using difference of squares again. Difference of squares appears a couple times in homework, and so knowing it well will make you a lot faster. I can now cancel common factors. The trick here is to remember what happens. On bottom, that should be obvious, right? We get x plus 6 on bottom. But what happens on top? Well, remember, when we cancel, you can always write a multiplied by 1 in a problem, because multiplying by 1 doesn't do anything. 3 times 1 is still 3, 5 times 1 is still 5, x minus 6 times 1 is still x minus 6. However, when we cancel, we had to have something left behind, which is why there ends up being a 1 left on top. Do not forget that 1, otherwise you will likely get wrong answers, or you will write it in a weird way that doesn't make any sense. So that is a common one to run into. Now, on our next one, let's look at, yes, I like that one. Okay, this one, we have example. Let's see, on top, we have 2x squared plus 14x plus 24 all over x squared plus 5x plus 6. Now, my goal is once again to factor the numerator and factor the denominator. It is important to note, though, that in this expression, you can always do a greatest common factor before you begin the factoring phase. So, example, in this problem, I can take a 2 out of everything, leaving me with x squared plus 7x plus 12 over x squared plus 5x plus 6. This is always an option. Now I can break this into my actual factors, which I happen to be able to do with the AC method again. So again, we do the AC. So my numbers are 1 and 12. My number I'm looking to get will be multiplying to 12 and adding to 7. That would make the numbers 3 and 4. This gives me the function x squared plus 3x plus 4x plus 12. And then group. I get an x to come out, x times x plus 3. I get a 4 to come out, x plus 3. So that means the top function would be x plus 3 times x plus 4 would be the 2 from the greatest common factor times the x plus 3 times the x plus 4. On bottom, I can again use the AC method. I have a 1 and a 6. I take 1 times 6 to get 6. I wanted to add to 5. That would be the numbers 2 and 3. So again, I take my spot. X squared plus 2x plus 3x plus 6, the group, and then I start factoring. I take an x out to get x times x plus 2. I take a 3 out to get x plus 2. They match, that's perfect. So it becomes x plus 2 times x plus 3. So I get x plus 2 times x plus 3. From here, I can simplify. X plus 3 cancels with x plus 3, leaving me with 2 times x plus 4 on top over x plus 2 on bottom. Now, there are two ways to write this. I could either accept this answer, or you could redistribute and write 2x plus 8 on top and x plus 2 on bottom. These two are the same thing, obviously, because if I distribute the 2, I get the same thing. It's important to note, though, if you're taking something like college algebra entrance exam for a college, or if you're taking something like an ACT or an SAT, either one of these may be your answer depending on the test. Like, an ACT may accept this answer and expect you to get this answer, but an SAT may want this answer. And so the ability to do both is very important. Just note the differences and how they kind of feel based upon what the problems look like. So again, the process doesn't change. It's just when we say factor, we can mean either factoring with the AC method or using a greatest common factor, because both are allowed at any point in time, any function. So in this case, we use a greatest common factor. Then we use the AC method. But on previous problems, we didn't have to do that. We just used the AC methods multiple times. So do note those different strategies you can approach with. Now, part 2. Same conversation. This comes down specifically to multiplying rational expressions. Let's take a look. Okay, I'll assign a couple of these tonight, but not too many. When it comes to multiplying rational expressions, there's a 4-step process. First step, again, you're going to factor the numerator and the denominator. Step 2, you're going to multiply numerators and then step 3, you're going to multiply denominators. And step 4, you're going to simplify by canceling common factors. You might notice that these contain the same basic steps as the previous problems, just with a little middle step here that involves multiplying numerators and denominators. So basically, if you can factor and simplify, then you can multiply as well. So let's take a look at our first example. We have here x squared plus 4x minus 5 over 3x plus 18 times the rational expression 2x minus 1 over x plus 5. Okay, step 1. I'm going to shortcut some of the factoring in here to save some time, because you don't need to showcase all the work that I'm doing. This first one factors into x plus 5 times x minus 1. The bottom would factor into 3 times x plus 6 times the second one, which would be just 2x minus 1 over x plus 5. So that's step 1. We factored the tops and bottoms of both expressions. And so you'll notice that in this case, the right-hand piece didn't need to simplify at all, because there's nothing really. And you can simplify now if we are possible, right? But we have an x plus 5, there's no x plus 5 in the bottom of this fraction. We have an x minus 1, there's no x minus 1 in the bottom of this fraction. We have an x plus 6, there's no x plus 6 in the top. And the same thing happens over here. However, now we're going to apply step 2 and step 3. We're going to multiply the numerators together, and we'll multiply the denominators together. Now, depending on who trained you and how you work, you may run into the instinct of, well, if I'm multiplying them, I need to go ahead and actually multiply them. But that's actually a mistake. When I say multiply, I don't mean to actually go ahead and start foiling this out. That's actually a pretty silly thing to do. What I mean is, when you multiply fractions, you put the denominators on top being multiplied. You put the numerators on numerators on top being multiplied. You put the denominators on bottom all being multiplied. So there's still a 3, there's still an x plus 6, there's still an x plus 5. They were all 3 in the denominator, and they still are. X plus 5, x minus 1, 2x minus 1 are all in the numerator, and they stay in the numerator. Now we do the same thing we did on the previous problems. We cancel common factors and write our solution. In this case, my solution would be x minus 1 times 2x minus 1 all over 3x plus 6. Now, just like before, you have the option to stop here, or you could go on. Personally, I recommend don't. I've never seen a math textbook that wants you to continue this process unless they're just being mean. Unless they really just want you to suffer like they have suffered. Like, there's no point in actually going through this process unless you're just getting more practice. And maybe that means you do want to do it. Maybe that means you do want to distribute this out and end up with, 2x squared, minus 3x plus 1 over 3x plus 18. Maybe you do want to go through that process. Maybe Maybe you do want to get the extra practice because you want to do really well on your next quiz. But you don't have to. This is an acceptable answer. That's what I'm looking for. If you write this other answer, as long as it's right, you're still going to get full credit. But if you make a mistake going from here to here, that's your problem. I consider that your mistake. Move on with your life. Second example, this will be our last example. Same process, okay? So you notice that these two, both this problems and the ones from before, all have the same feel. A lot of factoring, and then a lot of canceling. The trick is to making sure to factor quickly and effectively, while at the same time, looking for alternatives to do these problems a little easier. Let's look at our next problem. X squared plus 11x plus 30 all over x squared plus 5x plus 6 times x squared plus 7x plus 12 all over x squared plus 8x plus 16. Okay, just like before, step one. We're going to factor the top and bottom, and then we're going to multiply them together. So, first one, I'm going to shortcut this quite a bit. In this case, it factors into x plus 5 times x plus 6. It helps to know how to factor these quickly and well. This one factors into x plus 2 times x plus 3 times the next one. This one factors into x plus 3 times x plus 4. This one factors into x plus 4 times x plus 4. Alright, just like before. We're now going to combine these together into one big fraction with a large numerator and a large denominator. We're then going to cancel and then simplify. So, x plus 5, x plus 6, x plus 3, x plus 4, x plus 5, x plus 6, x plus 3, x plus 4. On bottom, x plus 2, x plus 3, x plus 4, x plus 4. So, just like before, we're going to look for ones we can cancel. I have an x plus 3 here, and an x plus 3 there, I have an x plus 4 there, and I got to cancel one of these two. And so, this becomes our new function. On top, we have x plus 5 times x plus 6. On bottom, we have x plus 2 times x plus 4. Many of you should stop there, but if you need the extra practice on making sure to multiply these through correctly, on top we get x squared plus 11x plus 30. On bottom we get x squared plus 6x plus 8. Both are acceptable answers, just make sure to stop where you deem it appropriate. If you need the extra practice, keep going. If you don't, stop right there. If you think you don't need the extra practice, maybe you should keep going anyways, because you could always use some. This will be it for today. We're ending a couple minutes early, so do note how we approach these kinds of problems. The same basic rules fit into both categories, so do note them. A lot of factoring in both sets, a lot of canceling in both sets. Make sure you practice your factoring today, and get that extra practice that you're going to need to make sure you can do these problems well and easily. That'll be it. I look forward to seeing you guys on Wednesday, and I hope you have a good rest of the day.